Okay. All right. So what I want to do today is to show off a couple of things that can make maybe the environment slightly more realistic. And sometimes it's just a matter of a couple of more tweaks that you can do fairly easily. So, there are two or three things that I'm going to mention. One is the use of the ambient occlusion. One is the use of the light shafts. And the third one is particle systems. And some of you have been using all three of these things. Some of you have been using a little bit of each. But I want to just sort of see how all these things can come together into one scene and talk a little bit about them. And let's see, we'll start by just creating the basic scene here again. The plane. From the top there. Okay. And I'm going to put the one building that we got from the asset store. You may have seen this building. This is this building here. It's from, I think, Shantytown or something. You can get pretty cool rundown buildings from there. And did it a little bit there. And I'm gonna put some trees in there as well. Like there. Okay. And the directional light, it is located there. I mean, usually the location of the directional light does not matter, but in this case, we're going to do some light shafts, and the position actually does matter for rendering that from the right direction. So we'll move it a little bit further up, this directional light. But in the standard skybox, the directional light, as you can see, the directional light is already lined up with the sun. And so if you use the standard skybox and the directional light that you're given, you can sort of guarantee that the light and the sun in the sky will line up. This is nice for the shadows being in the right place, for one thing, but it might also be nice for us now if we want to do some light shots later. So now we have this, and we have this shining on this scene here, and we'll put the grass on the ground as well. Here. And then I'll get rid of the main camera and put the first person controller. And I'm gonna put the first person controller, in this case, I'm gonna put it inside the building. Okay, so now I'm inside here, as you can see. And if I look somewhere up there, I should sort of be able to see the sun there. As you can see, that's the sun. The first thing I wanted to mention is that if you look around inside the house, I look at the place where the walls meet the ground, and you will, I don't know, maybe you look at it and say, well, I don't see anything wrong with it, but just for example, if you look in this down here, there seems to be a little bit of a disconnect. It appears a little bit almost as if the wall is floating a little bit above the grass, but it's not the case if it is floating. It is actually touching the grass. But it feels like it's floating sometimes if you look at your, maybe some walls that you created. Often because we expect that when two surfaces come together like that, that there's a slightly darker surface in that junction. And why is that? Why would we expect something a little bit darker in that corner? Yeah, look at that corner like that. That corner in the room. Look at this corner. This is a white wall. This is a white wall. They each have their own texture, diffuse, math, everything. Like when you bring them together, well, this is a little bit of a cheat because there's actually a hole here, so they don't actually come straight together like this. But even if these two walls have the same surface, and there's like ambient lighting in the room that would light every surface equally, when they come together like that, it is just a fact that the surface right here inside the corner only sees half of the world, because there's a big wall sitting in the middle. Like if you were in the corner looking up this way, you just see there's a big wall here, and there's just everything on this side is blocked, but this is unblocked. So this is the only chance you get to receive light, is only from that 90 degrees here. If you're out here on the wall, you get all these 90 degrees, and you get these 90 degrees, so you get more light. So all of these parts get more light than the ones that are in the corner. And we are talking about ambient light here. We're talking about light that is equally distributed throughout the environment. So everyone should have equal access to it. But the fact is that they don't have equal access to it. Certain parts, because of the geometry, those parts will simply not receive as much light. But in the standard model, there is no distinction between this part of the wall and this part of the wall. These two parts of the wall both receive the same amount of light. The same with the grass. This point in the grass and this point in the grass receive the same amount of ambient light. So that's why we get no difference, even if you're enclosing some parts with these type of junctions. We don't get any difference in lighting over there. This effect that we see in the corners and the darkening of those corners, this is called ambient occlusion. There is an occlusion. There's an occlusion that is basically the other geometry that is coming and sticking in down in there. This other geometry is occluding some parts, and it's occluding some of the ambient light. And we need to darken those areas if we want to create that same realistic effect that we expect in the real world. So we can do that, and I'm going to, let's see, yeah, we'll just stop this, and I'll go in there. I can just use this too. So one way to get ambient occlusion is to add an effect to the camera. And ambient occlusion, I mean, how would you calculate these things? I mean, of course, there's a way for you to create some kind of very geometrically correct effect that is based on really precise information about the different geometries that are interacting and where you are on the surface and things like that. But like to really understand, I mean, how much access each pixel has to light, that is a lot of computations. Like imagine like every pixel along every geometry is thinking about how much ambient light can I receive. That's a lot of computation. But one way to speed things up is to use methods that are only working in screen space instead of working in geometry space, where you walk along all the geometries in the scene and try to understand the coloring of each surface pixel of those geometries, and do lighting calculations. You can look at this image that you see here. This is the screen space image. just the rendering of that particular point shot there with the camera. And you can use information that is already stored in one of the buffers. It is called the depth buffer for this scene here. The depth buffer just simply tells us how far the different surfaces are from the camera. The things that are furthest away, well, they could actually be, they have a certain value. The ones that are closest to you have a certain value. And then using the depth buffer information next to this image, we can kind of see where we have things that are far away and then things that are all of a sudden a little bit closer. Like you can see kind of like edges, if you will, where the distances are drastically changing. And corners are places exactly where distances are changing in a certain way. So if you can use the depth buffer to almost find out where things are starting coming out, like this corner here, there's something coming out this way and something coming out this way, and the corner is a little bit receded in the back. The screen space algorithm is just working with these buffers, this rendering buffer and then the depth buffer, to identify places where it can then apply a little bit of a filter, a darkening filter. So this ambient occlusion that I was talking about can be done pretty much just like a Photoshop filter on a static image. It's done every time the image is rendered. So if you look this way, we'll do it again for that image, but it's only calculating it for the image that you're looking at at any given moment. Yeah.
So it's post-processing?
Yeah, it's post-processing. So it's already rendered. The whole image is already rendered. But the darkening of corners can be done in screen space. And that's why I'm going to the camera here. I'm going to the camera and I'm adding an image effect. All the image effects are done post-processing. They're all done with the image. Like these are basically Photoshop filters. And I'm going to do here, screen, it's called screen space ambient occlusion. Screen space meaning that it's working just with the screen image. And I'll turn that on. Did you see what happened? I'll turn it on and off and you'll see. From this to this. And you see the difference, yeah? and now we can actually we believe that these two things are connected now, whereas they seem to be disconnected before. And you can play with these parameters, like the intensity, like is how dark it is. Like you can really make them dark. You can also play with how blurry they are. If they're not blurry, then it's kind of like a spatter of dark black things there. But this blends it a little bit more. And then the radius is how big these things are. So this might be connected to maybe the scale of objects that you are working with. If you're working in interior environments, maybe you want to have a certain scale of these things. If you're working with large buildings on the outside, maybe you want to make them a bit bigger. Yeah.
So if that's like, how do you actually customize? Because it's all in the
in the camera.
Yeah.
Then I'm thinking like you have to compromise, and like what is the main focus of your environment? Is the main focus outside outdoor environments, or is it mainly indoors? That would make different settings.
Could you not
dynamically change?
Processing this, you can't do anything to customize.
No, you can't. You can't. I think, well, unless you actually go into the shader itself, and I'm sure you could do something like detect what kind of objects are in the scene and then switch. Yeah. And you can also, through scripting, you can turn these things on and off. And you can have several of them, so you could maybe turn from that one to this one when you go outdoors.
Because what different materials have different?
No, this is not based on the material.
Yeah, but in reality.
In reality?
So if you want to, like, if you're going for a render of some sort.
And yeah, you have brighter surfaces that would maybe, like, they would be more reflective than others. And
yeah, so if you would
brighter.
Really bright box right next to
exactly.
one, you would not have the same.
So this should always be also in conjunction with whatever material is behind it. So this is blended with already the reflectivity of the material. It's not written over it. So if there is a very reflective surface here, that should still be a little bit brighter than the non-reflective one.
Yeah.
So yeah, it is transparent, and you can, like the blurring will kind of blend it even more with the environment. So maybe now certain parts are more subtle this way, actually, when you bring out the objects. But yeah, but still, I mean, what we are doing, we're pretty much just cheating. I mean, this is a cheap. I mean, you saw the effect, right? And it's a cheap way of achieving this effect, and it runs fairly well even on older processors because it's a screen based.
But it's still performance heavy.
It is still performance heavy.
Yeah.
Okay. Sorry.
It's not completely accurate.
And it's not accurate. No.
Not accurate at all.
No. And well, let's see.
Especially at the seams of, the camera.
The seams of the camera.
Yeah. If you look at corners, how it changes when you move around. It sort of appears out of nowhere. You can see it if you look closely.
Yeah. But you're right. I mean, it is. The thing is that this is.
Fades in as you look at more at the corner.
Yeah. This particular environment is really well suited for this. It's like everything is the same here. There and these lines, we have very stark, clear junctions in this particular view. If you go outside, you have many different objects, and one of the worst ones, which you will actually see, is the trees. You will see a weird boxy black effect up there, which is quite horrible. And I was kind of looking around for some solutions to that, and there must be some, but still people were kind of just, well, too bad. This is one of the downsides. You get artifacts, and maybe this is something, I think it makes sense in certain environments, like indoors like this. It makes sense to do it. Maybe in outdoor environments, you want to be a little bit, if you can, avoid it where there are a lot of trees. But now you're at least aware of what ambient occlusion is and is capable of. And there is also ways to do the accurate version of ambient occlusion and bake that into light maps ahead of time. You can even use Blender to build or to render ambient occlusion for your models and render that and basically bake that into a texture that you then apply to the model.
So is that like digital release things? Like how do they do this in like really big games?
They bake as much as possible of these things. Many layers of information about the lighting of the objects. I mean, the normal maps and everything like that, and including these light maps that usually have the ambient occlusion already built in or baked in. So I could take this model into Blender and I could make Blender do this for me, and then I would store the texture and then apply that texture on top of the albedo texture.
Like dynamic situations, or
only static ones. Yeah. If you want to play with baking things in Unity, the thing you have to do is to select your models, like this building here, and you have to make it static with that button there. As soon as you click static, then the baked lighting will occur. I think, let's see what happens actually to static, and it starts baking down here. You can see it's actually now it's baking some lighting information into this model.
That makes it run a lot faster.
And then at runtime, then that's information just already there. It doesn't have to light it again. And you can select, which ones are going to be baked, which ones are going to be real time. So you can try to optimize this. This is one way to optimize things. But it didn't make a lot of difference for us here, but we can tweak the lighting engine for Unity, and then you can get a little bit more realistic lighting baked in here.
You can see the performance you get by putting the stats in the game.
Yeah, in here. Yeah. You mean going from static to dynamic? Yeah. Exactly. This is definitely something that those of you that are working on laptops should truly consider, is to make as much static as possible in your scene, and just let that be like a one-time process to make the lighting for those objects. Let me get to the next thing here, which I wanted to. Let's leave it there. Well, it's a little bit dark. That I think it's, instead of having it that intense, maybe make it a little bit more subtle. Well, okay, I'll leave it there. Okay, so the other thing I want to do, other thing was, one thing that maybe I would like to do before we do the next step is that you see that everything is blue inside here. And I find that a little bit unrealistic. We're inside this building here, but why is it blue? Even if there's no direct light on it. This is the shadow part. It is all blue. Yeah, exactly. So the ambient lighting in the lighting model is taking its color from the sky. And I think when you're indoors, especially, you don't want that. You know, especially if there's a roof and the sky is just not even there. You should definitely think about that. And you go into the lighting panel here, and you will see that the ambient source is the skybox, and that is why everything is blue inside. You might, especially for indoor scenes, just make maybe even just a single color, and you will see that it changes. And you you might also think about kind of the warmth of the environment. So if you want to do like a warm sunny day or something like that, maybe you want to give it a little bit of a warmer color or a starker, whiter, bluer color if it's that like soaring hot. But like here we have changed it a little bit, and I think there's already a feeling of more realistic than that strange blue hue that was earlier. And it's a little bit, and the shadows also get a little bit darker, which is nice. You can really play with the intensity of the ambient color to make the shadows darker. So if you're dragging down this a little bit, now the shadows become much starker. And that's kind of nice. So now we're really inside the dark house here. And there's the sun, but the sun doesn't feel very interesting to us at all. It is just that the white spot there on the sky. Yeah.
So is there no bounce light calculation?
These are all bounce lights also, yes. They call it reflected light. And you can control the reflected light intensity so that you can have them reflect less. So basically, things like, the light falling on this surface here, this will light up these walls over here and these walls over here. But you can reduce the effect of that on this wall by reducing the reflected intensity in the lighting model. So that is one thing you will probably realize. I should point this out. When I took the building in, when I took this house in from the asset store, it was an old model. And when you select it, you would see that the materials that came in with the old building were legacy materials. They were identified here as legacy shaders, basically old and outdated shaders. What you want to make full use of the lighting model, that is the physically based rendering that Unity 5 is now employing, you have to change these shaders to the standard shader, or basically the up-to-date shaders. And when you do that, you typically end up with something that is actually too bright, so because now, because the new lighting model is using bounced light as well as another source of lighting the model up, then it's receiving a lot of light with the new shaders. And then you can tweak them back. You can reduce the intensity of the ambient light, or you can reduce the intensity of the reflected light and tone it down again. But let's see again. We are in the building, and I'm gonna just rotate this one a little bit so we can see the outside again. Okay, I'll put them here and rotate this way, and I'll rotate up a little bit. Here we go. So now this is our view. Let's see if we can do something with this. And now you see the sun is out there, but it doesn't really. Somehow the sun doesn't penetrate somehow this building that we are in. Doesn't feel like it is, at least. So I'm going to add another effect, and this is the shaft here, the sun shaft. And I'm going to, one of the things that it asks for is the caster of the shaft. And now I'm going to take the directional light and make that the caster. We're still not seeing a lot, but you can see a little bit of bleeding there, happening there. Like the light is kind of squeezing in there. But now we can play with some of these parameters. And the distance followed, this is actually how much it just it's the inverse of what you would think. You would want something more, and therefore you put to the right. In this case, if you want more light coming through or bleeding through, you want the fallout to be as little as possible. This is actually how much it drops in the intensity over distance. So you want to let it drop very little, then you have a greater effect. And then let's see the intensity here. We can do the intensity of this, kind of squeezing through there, a little bit more intense. And then we can do the size. Now it's really stretching through there. This is just how much the blurring is spread out. And then there's a threshold color here that is a little bit interesting. It seems like it's this is like if this was a flood fill or something like that. It's just how much of it washes over the other colors that are around you. Like it's kind of like swallowing the other colors. Maybe it's too intense. So you can play with this here. Maybe there. And then the actual color of the sun, you can also change the edges a little bit to be warmer again, like that. Okay, so if we play this, we are here. And now you can see this, oops, I got stuck. You can see the sun kind of trying to squeeze through there. Oh, I keep getting stuck with my first-person controller. There's some junk here. Oh, I see. I'm a little bit. My first-person controller is rotated. Oh my god. But it's this this one. Okay, now I'm set again. I'll just do this one. I'll just do this once again. Okay. What's up? You can see the sun. Oh, I keep getting stuck on some kind of a windowsill there. And you can also see it through the leaves of the trees, which is kind of a nice effect also. So that was the, you can play with this, and if you're outdoors and you have, especially if you have openings that are open to the sun, and then this is a nice thing to get to see. And actually you can do a lot more intense than this. Let's see. Do things like like that. Okay, this is really crazy. A little too much. Ouch. Hey, I have to turn off this notifications. Let's see. Last thing I wanted to just add was that often inside, well, one thing that will add a little bit of detail to the environment are some kind of movement in the air. And in an environment where you have a strong sun like this, you often get, you actually see the dust particles around you. And that's a nice thing to use a particle system for. So I'm going to put a particle system in there. Well, these are not very good dust particles, are they? They're kind of crazy and big. So this is the default particle system that you get. And I'm just going to tweak it a little bit to make it more like dust particles coming up or sort of swimming in the air. And particle system you may be familiar with. It's basically just an engine that generates vertices, and these vertices are just points in space. It generates them from an emission surface, and then these vertices or particles, they travel through space, and then they can be made to change some of its appearance parameters as they traverse the space. They can change color. They can even change directions according to some forces and things like that. Change speed and things like that. So it's like every little dot that you see, every little particle is like a living being that has a lifespan, and it comes into existence from this emission surface, and then something happens to it and it dies at the end. This so one thing that we want to do immediately is to change the emission surface, because the default one is some kind of a cone where they all are emitted from a single point and then spread out like that. That is not what we would expect dust particles to do. They kind of just hover around in the air pretty evenly. So we'll go into the emission, we'll go into the shape. Yeah, the shape. And this is the shape of the emitter. And we will change that to a box. So now they get generated from within this box here. And then we can place the box properly, and we can place it maybe in the area where we see the sun, the strongest amount of the sun here. So maybe we can take it and put it over here, and we can also change the size of the box. Oh, it would put it too far out. I can make it bigger in different dimensions. Okay. So this is a box that is in there. Okay. So it's a box that is a part of, maybe a little bit lower here, like that. Okay, and then we want to make them move slower and not as crazily as this. And we want to do the start speed to be much lower. So now they're going very slowly. And This is the start speed. And we want them much smaller than this as well. We can actually, in the render part of the particles, we can also say the maximum size of a particle should be something a little bit less than this. 1.5. I'm putting them really small. Oh, is that too small? Oh, okay, that's maybe too small. Okay, can you see them now? You can sort of see them, yeah? So this is changing the size of the particle size. They also seem, yeah, there's one there. It's kind of a short, yeah, sorry.
When you're doing particle effects of this scale, isn't it cheaper to do in post-processing instead?
It probably is. It's possible to do it in post-processing. Yeah, it certainly is. But it might still be tricky to see the interaction with somewhat complexer geometry, maybe.
But like these particles, do they interact specifically? Like if they go into the shade, do they disappear?
Yeah, you can have them use the lighting information and just take on the color of the lighting. Yeah, they can receive shadows.
And that fits the post-processing.
Yeah, that does. And also, when you move around in space with them, you would expect that you can get closer. You would actually expect a parallax effect.
Yeah.
If you walk this way, you want to see the particles kind of shift around in space in front of you. So probably that's another thing that makes it a bit more, makes more sense to have it in here. I'll have it a little bit bigger so you'll see them. There's not that many of them, but the emission rate can be increased so that I'll have more of them. They're going to be maybe now there's more of them being emitted, but they seem to kind of come into existence and then drop out very drastically. So they just kind of pop in and pop out, and this popping effect is really annoying. So what you can do about that is that you can look at the color over the lifetime of these particles. So if you add the color information about the particles, you see that the default color is white. But if you change this, you can actually select the color. You get a gradient editor. And the gradient editor has two parts. The lower part is the color information. The upper part is the alpha information. Like the upper part is these two markers, and the lower part is these two markers. So I can, if I want to change the alpha gradient, I can add a marker here and add a marker here. And then I can set this marker on the alpha side to 0, which makes them completely transparent. And I can make this marker on the other end of the gradient also 0. So I have now changed how the alpha goes from fully transparent to full color back to transparent. And this is already taking effect. You can see it in here. They're no longer popping in and out. Look at how that little dot comes in and then shows and then fades out. This is one of the most important parameters of any particle system, is to use this effect to get rid of this popping. Pretty much any effect you make with particles has to consider how they come into being and how they are taken out of the environment. Maybe white is not the best color. So for dust, so you can go and change the color also here at the lower side, which is the color information. So you can change it to, I don't know, more grayish, I guess. But you have to change it on both ends because this is a gradient. So now you have changed it more into something more grayish. And here we go. If we go into the environment, we should now see these little particles in the environment. There's one thing that is a little bit, well, maybe more than one thing that's a bit disturbing. One is that they all move in unison. They all seem to be moving at exactly the same rate. And it's if you say that there's some kind of a wind current or something going on in there, then maybe you would expect them to not all move so incredibly uniformly. So you can say the start speed here of the particle, you can change that to a random between two constants. So the start speed can go from maybe 0.01 to 0.05, something like that. And now in the environment, you should see some of them moving a little bit faster, some of them moving a little bit slower. And that's already a little bit more realistic. So I'm not going to have time to go into more detail about this, but you can see that the particle system is useful to add slight moving elements, small or big, into the environment. And I really recommend you look at the starting color, the end color, and how they fade in and out to make it more seamless, and also try to randomize things, try to make things random speed or size or something. Yeah.
Sorry, one thing, because they're like more visible in the dark areas than they are in the light areas.
Yeah, that's just the contrast. Well, let's see. Did I not make them take the shadow into effect? So I think it's receive shadows. It is receiving shadows, so I'm a little bit surprised that they would not then be. Well, we are seeing them against the back, this background, but possibly the light, they're actually further out. So possibly they're actually going through light. That's a possibility. I haven't really investigated exactly, but they should be being lit by the light source. And I think we're just seeing the high contrast as making them feel brighter. They also come into existence and they grow brighter during the middle part. They kind of have a short lifespan. So one thing to play with would do to extend their lives a little bit. They can get a little bit further maybe. But, maybe a little bit too much. You would probably spread them out a little bit more. Now the fading only occurs at the very end and the very beginning. You can make the fading part a little bit longer in both ends to have more fading happen. This type of dust thing is one thing, but I also suggest that if you have an outdoor environment, you should, one thing that's very common is to use pollen, like simulate some kind of pollen with the same method. And you have something moving through the air around trees and things like that. It really adds to the effect or the atmosphere to do that. And here we are just rendering dots, but the actual rendering, we're doing what is called the billboard render mode. Just creates like one dot mode. You can actually have a little bit of paste a little bit of a texture on top of it, and it will always face you. But you can actually choose a mesh. So if you have a mesh of a leaf or a trash or something, you can actually put that in here, and you can have these leaves floating around the environment, like really proper objects. And then use the particle system to control their movement. Okay, I think we'll stop here, and we'll see you on Friday. And I'm thinking also that I'll see what I do on Friday, but it's very close to the second programming assignment delivery. So maybe there's some way we can use Friday lab also. I'll give it maybe a little bit more freedom to what you do, because I would like you to consider for the second programming project, consider these effects or some ways to make what you're doing more realistic, or in some ways, more atmospheric. So you might actually be able to work on that in the Friday class, as long as you're trying these things out. So we'll see how we do that. But all right, thanks for today. Oh, you have to